Okay, we're ready to go. Guess we'll turn this one off, or it's not going to cooperate. We had our first meeting. What's today? Today's Thursday. We met on Tuesday. Okay, so I think I turned this on, right? Okay. Okay, hopefully it all comes out. So any questions from the first day of class about the syllabus, things that you might have looked over? Are you ready to dive in? Sure, why not? Okay. So today we'll go into dimension and measurement class presentation. So there is a textbook. So the sort of the anatomy of each lesson is we have the textbook, which you can pull up and take a look at. You might want to scan over, look at examples and such. You could do it before class, you could do it after class, do it during class if you want. And again, if you have the printed textbook, that's what you get, but you've got a PDF in here, so you don't need the printed textbook. Chapter 1, mini lessons, are those required? No, good. They're there because they're basically the way the online class gets their instruction. So you might find them helpful. There's several different videos with some work to do below it to kind of help teach it. But so I leave them in here for each of the lessons, but you'll see when you pull it up, it says 50 points, but notice Canvas says 0 points. So they're just there if you need them and if you want them, but you don't have to. Chapter 1 homework, that is worth 15 points, and that's kind of the basis of the class. Okay, so that's how you'll work through and learn the content. There's somewhere between 40 or 50 questions in there, so it really is designed as a whole week's worth of work. So what we'll do is today we'll get the instructional part that will help you get through most of those problems, work through them. Next Tuesday will be our work session. So that's what this class is, a 5-credit class. The content really is a 3-credit class. It's the same content as in a 3-credit class here or ASU or anywhere else. So we get an extra 2 credits for assisted work. So and we'll always use sort of, at least for this first part, Tuesday class will be to come in, get tutoring, we'll work through things. There's not going to be really any instruction. If you get through the homework at first and come to class, well, what are we going to do? Well, the homework, I'm already done. Well, then you can head out if you want, or you could get ahead, however you want to do things. But that's sort of a good thing, is if over the weekend you're able to get through all the homework, maybe you don't come on Tuesday. It's all up to you. If you aren't getting through it, though, please do come. We can work together through it. We'll get you there. Okay. I had one student, and she came all the time. She never had any questions either, but she would come on those Tuesdays because she said, if I stay home, I don't get my work done. If I come here, there's nothing else to do but get the work done. Okay, that's fine. Sometimes she'd have 1 or 2 questions for me. That's fine. Okay. And then the homework quiz, that's what we're going to work through together at the end of the lesson. So we'll do the lesson. We'll come in, and this sort of this lets us know that I've taught everything. If I've missed anything, usually it's in the quiz. And again, you will have that quiz. You'll need to do that yourself, but your questions will be slightly different than mine. And what I mean is your question will be the same, but the numbers will be different. So again, you could try to work through them as I do, but at the same time, I'm going to kind of give a way to work through it. And then these same 6 questions that are in here are also in the homework, so it's kind of a good way to get started, to know that we know how to do most of the homework. There is some problem solving in there, so it might be that, hey, we didn't specifically go over this type of question, but you should have the foundation to do those types of questions. How much of the homework do you need to complete to earn the full points? 70%. Good, you were fast on that one. So yeah, good. So 70% of the homework will get you 100% of the points. I have to manually do that otherwise. So the system will show you. You'll see instead of 15 points, whatever 70% of 15 is. But I think it's like 12 points something. I did this before. As soon as I see you make to that, eventually I will up it. Typically I do it as we move through because even though you're at 70%, maybe you still want to work through them later. So, but by test time, I will update those. So anything at 70% does go to 100%. All right. And then what you'll see in some of these, there's a PowerPoint, and I will go ahead and I do have videos of some of these because I presented it like spring semester. I had this class. So you could go to I have a YouTube channel where I'm going to post these. So once I post these, you'll see it and it'll be in that same directory. So if you go to my YouTube channel, you'll be able to see previous ones. And again, they may be useful or maybe not, but what's it doing? Wow, it's a big file. Oh, I think I've got videos in here. That's what's going. Okay, it's coming. But I got two going now, so. Let me get rid of that one. Let me do this, I think. I have everyone except this one here. I'll speed it up a bit. well, we'll wait for the PowerPoint a little bit, but until that time, go ahead and do a lesson. This won't go on the video very well because I'll have to be doing it up at the board, but I can post a previous video. It says it's going to take 23 minutes to download, and we don't want to just sit here for 20 minutes, do we? You might be done in 20 minutes. So, okay, so measuring and dimensional analysis. So let's talk about what are the types of things we measure. Why do we measure things? Why do you measure things? So to be precise, but why do we need to be precise?
You're renovating a home.
Okay, we're doing something, we maybe need to tell somebody to build a cabinet for us or something to fit in this space, right? They need to know measurements, right? We maybe are in a business, we're going to make tables like this. We got to be consistent. We got to be precise in what we're doing because people want to know the size. Is it going to fit in their stuff? So that's where measurement comes from, is we want to know the size of things. So it's a numerical number we come up with. What do we need to be able to measure something?
Dimensions.
What's that? Dimensions. And what else? What's a part of the dimension? What? Some kind of a unit, right? And we could use centimeter, like we've got ones that we use here, centimeters or inches. Those are pre-established ones that have culturally been made. But there's all sorts of ones. In Egypt, they use the cubit, which was the measure from the tip of the finger to the, what's this called, elbow. So they would measure like this. Again, each person's cubit might be a little different, but they were close enough for some of the work. So sometimes you don't need to be completely precise, although they were with the pyramids. But a cubit would be this, and they probably had a pre-established royal cubit or something that was in gold or something, and this is a special size. But that was so sometimes we use the measurements for ways to sort of estimate. I don't know if you've ever done sewing and stuff. Sometimes it needs a yard, and it's approximately a yard from the tip of your nose to you hold your finger out here. My 4th grade teacher taught me that. You need a yard, you go like this, and you got a yard. Okay. Of course, for a kid, that's different than an adult, right? So, but anyway, you find ways to measure, maybe using your body, that get you pretty close. I know I'm a 10.5, sometimes an 11 size shoe, and it's almost exactly 12 inches. So I can pace off, and I can get pretty good, accurate measurements with these boots on. Another pair of boots are a little bit bigger because they were cheaper, they were left over. But sometimes, so you'll find things where you can use it. But we need units. The other thing we need to be able to communicate is, again, thinking maybe in the past where we're more tribal, we have to communicate with our neighbors, and they might have a different system. So, and we have that. We measure in inches. Europe, Asia, whole rest of the world measures in centimeters. So we have to convert, right? So that's part of the lesson, is we're going to talk about sort of getting a feel for what units mean, how size. So if I say I've got 100, is that a lot or is that a little? It depends. If I say grams, 100 grams is not too much, but 100 kilograms is pretty doggone heavy. So the units make a difference when I measure it. And what do I measure? I measure size, I measure weight, I measure volume, how much we can get in, space inside things. So there's various types. We measure time. What else do I? So size, which includes length. Area, so which has 2 dimensions, a length and a width. So we get into that a little bit. Volume, which is 3 dimensions. We do measure weight. We measure time. Temperature. How could we forget that in this climate, right? So those are all different types of things we attach a number to, and when it's this hot out, we put this number on it. 113 this weekend, right? We kind of know what that feels like. But again, also 113 feels differently here than maybe in Thailand or Houston where it's humid. 113 and humid is a lot different. 90 and humid sometimes is worse than 113, right? So, yeah, we got too much. So I'm just trying to think what we do. So part of it is, okay, we've got two measurement systems. We'll call it the American system. When I was growing up, they called it the British system, but the British don't use it anymore. They've gone over to the metric system because they got in the European Union and everything. So it came from the British, but the American system. And for length, what do we use? We use inches. We use feet. Any football fans? What do we? Yards. And if we're driving or riding a bike, miles. So those are all different units, sizes of units. There is some relationship between them. Feet is going to contain 12 inches, right? Because the way we do is inches are sort of the smallest, but they divide those inches actually into sixteenths, so we could go down to 1/16 of an inch. Yards, we can refer back to feet. There's 3 feet in a yard, so again, it's just a larger measure, but instead of saying we have 30 feet, we could say we've got 10 yards, right? You could also measure yards in inches. So since there's 12 inches in a foot, there would also be 12 times 3 is 36 inches in a yard, okay? And then miles, the longest distance. Does anyone know how many? I don't know how many inches are in a mile, but there are a certain number of feet in a mile.
5,260.
I think it's 80, but that's one of those things that I kind of I remember the 80. You helped me with this. I couldn't remember if that was a 2 or a 3. But some of these, what it gets at is we're going to have to look them up. Right? We don't have to memorize all these, and actually, if you look in the book, they give you this stuff. But if we're going to convert from one unit to another unit, we need to know some details, right? If I want to convert, I've got the feet. I need to know how many miles are. So I got 10,000 feet. Divide out. That's 2 miles, almost 2 miles. But I think it's But maybe don't write that in pen yet because I'm not quite sure. We'll take a look up. In fact, let's do this. We'll just Google it. How many feet in a mile? And see it even anticipated, 5,280. Okay, so part of what we're going to do today requires us to look things up. There is some, the other thing we'll see is there some conversion apps. So when you go to take exams, there'll be paper pencil, but I'll let you use your phone. I'll let you use your computer if you want. That's fine. Any tools that you find. I think I've got a calculator here later that does financial math. It also does unit conversions. So these days, we can just type it up, and sometimes even Google is making it right in here. We can choose what units we want. We can tell them how many feet we have, or we could say I have 1 mile, and it converts it over to feet. Or I could change this into yards, and I could say I have 10 yards, and it'll tell me I've got 30 feet. So there's right there, you can look up, you can check your answers. Okay. Some of the homework, they're going to have you do some conversions. They will give you a conversion factor, and I'm going to show you how to use that, sort of the math behind it. And sometimes your answers aren't going to match when you use a calculator. The calculator is actually going to be more accurate. We're going to give you maybe a conversion factor with maybe 2 decimal places, and maybe it's not, to be real accurate, you need maybe 3, 4, 5 decimal places. That's what the beauty of the calculators. They have all that built in, whereas sometimes we just give you like going from inches to centimeters, we're going to find we use the factor of 2.54, but I don't think that's exact. I think there's like 3 or 4 more decimal places. So if you use a conversion tool, it will give you an exact value. The 2.54 is giving you a close estimate. You're close, but it may be different. So if you put that answer from a conversion calculator, it may be marking you wrong. It's not that you're wrong, it's just you're more accurate. okay? Um, and I think eventually it does show you the answer. So if you're close, I'm okay with that too, because for most calculations for units, close is good enough, right? One of the things we find is also if we're off in the third decimal place, could we actually even measure to 3 decimal places? I don't know about you, but I can't. I can maybe get, to 1 decimal place if the measuring device has that, but so that's the issue. Okay, so let's just take what we have and let's see how could we, if I knew I had 47 inches, how can I convert that into sort of feet and inches? Divide by 12. Why?
There's 12 inches in a foot.
There's 12 inches in a foot, and I'm going to show you how we can do that. So the standard thing we're going to do is whatever inches or whatever unit we have here, we need some way, and we know we're being asked to go to some other unit. We'll say in this case it's feet. What we need something that tells us how many of one unit is in how many of the other. So, and it doesn't have to be 1 and 12, whatever, but whatever these numbers are, what happens, and this works with unit conversion. You'll see this if you take chemistry, this will come up in your chemistry classes. But the way they convert is this gives us a ratio, a fraction. Gives us 2 fractions, actually. It either gives us 1 foot in 12 inches or 12 inches in 1 foot. I'll abbreviate that way. Okay, so those are 2 conversions. Now, if I have 12 inches, what's the difference between 12 inches and 1 foot physically? Could you see the difference between, if I held up 12 inches here and I held up 1 foot here, could you see any difference? No, because they are exactly equal, right? They are the same thing. They're just different numbers of measuring because one's a smaller unit, one's a larger unit. But 1 foot, 12 inches, as far as length, it's going to be the same piece of wood, right? So it doesn't matter. My PowerPoint gets me to this, so what happens when we multiply by 1? You get the same thing. I don't know. When I was a kid, I was really impressed with myself because I could really multiply by 1 quickly. I went to my dad. Dad, I can multiply by 1 real quick. I don't remember what grade it was. Here's my dad's a rocket scientist. He was actually a rocket scientist. He worked for Boeing. He worked on the 12th chamber engine of the Apollo rocket when they were going to the moon in the late 60s and stuff. So he had an IQ at genius level. I was not close to that, but I thought I was. So I said, yeah, give me 27 times 1. It's 27. I was so smart, But here's the thing is, what is this? The other thing, if we take a number and we divide it by itself, what do we always get? 5 divided by 5 is 1. 27 divided by 27, that's 1. Again, genius level here. I thought, like, Dad, look what I can do. I can divide something by itself real quick. So that's going to get 1. So 1 foot divided by 12 inches is actually 1 because they are the same thing. Now numerically it doesn't make any sense, but they are exactly the same thing, so we can say it's a unit of 1. So if we take this and we multiply it by 1, are we going to change it? No. The numbers will change, but the amount of stuff we have won't change. And so the way we remember that we're dividing, and actually when we do a conversion, we either multiply by a number or we divide. Sometimes I forget which is which, and the way we can know that we're going to divide is we're dividing out the unit we don't want. We're going to multiply by the unit we do want. So since we want feet, we want that to be in the top, inches to be in the bottom. So there's only 2 choices. And if you're like me, I always make the wrong choice first and mess it up. And, that doesn't seem right. I must need the other one. So we're going to divide out the inches. We're going to multiply by feet. So this is the way it works. We take this and we multiply by this factor of 12 inches over 1 foot. The inches actually cancel out. They sort of divide out. And then what it tells me is I'm going to take my 47, is 47 times 1, right? The inches are now gone, so there's just a number there, so 47 times 1 is 47. I divide by 12. Didn't choose a real good number to do that. How many times does 12 go into 47 evenly? Almost 4. If I would have went with 48, I think we'd be at 4. So it's almost 4 feet. It's 3. Let me show you something. Anyone do that with a decimal? Just take 47 divided by 12. 3.91. Okay, so what I'm going to show you is how you can do this now. So what we know is it's 3 feet, because that's the whole number. And there's 0.91, not 0.91 inches, 0.91 of a foot, right? But how many inches are in a foot? 12. So we can take 0.91 times 12. We should get 11. This worked out. 10.92. So we've round up because we realize we got 47 inches. So we can do this because actually it wasn't probably 3.91. It's probably 3.91. Blah 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 blah. But it gets us close enough. 10.92. Okay, that's got to be 11 inches. The other way to do is that 3 times 12 is 36. So you do 47 minus the 36 inches. That is the 3 feet. And you'll see you'll get 11. So, and sometimes in the text they'll ask you for this is what is 47 inches in feet and inches. So it's 3 full feet with 11 inches left over. Okay, but this is sort of a trick. Is our calculators won't do this for us. Well, some of them will, but they'll tell us if we do the division 47 divided by 12, we get a decimal. The whole number answers how many feet. This decimal is, say, if we take 12 times that decimal, that will give us close enough to what's left over, and then we just round it up. It's actually 11. Okay, does that make sense? Okay, but here's the whole key. This is like, I don't know, 60% of the whole lesson is to know to do this. We're going to give you a measurement. We're going to ask you to convert it, and every conversion can be done by simply taking the fraction from the piece of information, the fact that we had to go either look up or be given, right, or know that there's 12 inches in a foot, and do it. Now some of you would just say, oh, you just divide. Oh, you just multiply, because if I had 30 feet and I want to go to inches, oh, just multiply by 12. Okay, some of you will be pretty intuitive at that and you'll get it right, but sometimes we're dealing with units that we're not really sure of, so that's where it helps. So if I got 30 feet and I want to go to inches, what do I multiply? I've got to divide out the feet. I want to end up with inches. That's where I would use the second one. Okay, so it all starts with an equality. This many equals this many. I can make 2 and only 2 fractions because they're reciprocals of each other. And then I just got to choose the right one. And again, if I've got feet, I've got to use the one that have feet, the denominator, because I want to end up, I want to divide it out. So in this case, I would put 1 foot, and I'd put 12 inches. The feet would cancel out, and now it's just a multiplication problem. So some of you would say, yeah, that's all you do is just multiply. That's fine. But just notice that that's coming from this little system, which is called unit conversion. They'll use it in chemistry a lot. Some of the problems actually, they want you to set up that middle so that you're choosing units and you're choosing values. While it doesn't, I mean, you need it sorted to get to the answer. You could do it another way, but there will be some, we'll take a look up, where you'll actually set it up. Okay? But every conversion is that way. So all of it is questions, going miles to feet. We need that. There's 1 mile and 5,280 feet. 5,280 feet is 1 mile. So this is it. It gives us 2 fractions. We can go here. It gives us either 1 mile, 5,280 feet, which is actually, right, because it's a form of 1, 5,280 feet. 1 mile. Just trying to see if I got my... Did it ever download? It looks like it did. Okay. Okay. So we're ready to go. We'll skip over some of these things. That just so this actually I use from, this is somebody else's PowerPoint, but a little bit on measuring. So you do not measure success by today's harvest. Measure success by the seeds you plant today. What does that mean? Measure things into the future. What you're doing today, like you're planting seeds so that you can get a career that you'd like to have, right? You get more choices in life. Reason I included that was Robert Louis Stevenson. That was actually my first grade classroom. I started was in Florida at the time. My dad again was down in Cape Canaveral working on stuff. That was the name of my school, Robert Louis Stevenson School, in first grade. That's the only thing I remember from first grade, but I thought I'd use it. So, what does it mean to measure something? We talked about that. Einstein said, not everything that counts can be counted, and not everything that can be counted counts. So we measure things, but part of the things we're going to see in this class, we'll get into statistics and stuff. There's a lot of things that humans are trying to measure, and a lot of things in our world are done to try to stratify people. Okay, this person's the best, this is next, this is... so when we're trying to stratify people, I don't know. It doesn't make for a nicer world. But if we measure ourselves against ourselves, how can I make myself better? I think that's a valid thing to do. But to compare ourselves to others, hey, there's really no comparison. Someone can do this better, but I can do that better. Okay, so I think that's what Einstein was getting at. So we'll go through this, and again, this is for teachers. So one of the types of measurement I was getting at would be like a perimeter around a building. So that's just a linear measurement, and so the perimeter for our room would be maybe represented by the baseboard. How much do we need? How many feet do we need to buy a baseboard? And that's just a one level thing. I'm going to skip that because the sound's not. If you want, like I said, go in. I think I have those recordings in there. What it does is it takes you into an archaeological site in India, Mohenjo-Daro, from 3,000 to 5,000 years ago, and the stuff they found in that city. And even 3,000 years, they had flush toilets back in India. Sometimes, and my wife's been to modern India, and she says there was times where there's no flush toilet here. It's just basically a pit you have to go into. But thousands of years ago, they had cities set up with plumbing systems and watering systems and all this sort of stuff. And they had a standardized brick that they used to build things, and they had a metric system long before ours and that we use. So now we're going to get into this. So what are some of the things we use? An inch. It's a one-dimensional. It's a linear measurement. If we need to measure like how much carpet we need, we start talking about area. So that would be an inch by an inch. So the actual units, though, would be called inches squared. When we're measuring, we're actually measuring with a square. If you think of it, how many squares. And our carpet here is kind of nice because it's big squares. This looks like about 2 foot by 2 foot. So it's 2 times 2 is 4. Yeah, it's 4 feet squared is each of these. But we could, we could lay them out and we could count how many we are, how many it would cost to do here. But there's calculations we could do. We could measure that side and then we could measure this side and multiply them, and that would tell us also how many of those units we need. Volume, as I was talking, so that's the length times the width times the height, so that's going to give us how much space, how much volume is inside of a building. And again, that it means something to some of us. My brother's a longshoreman up in Tacoma, and he's loading and unloading containers all day long, so he's got a pretty good feel of this box is this size, how many of those boxes will fit in that in where I'm going, because he's the guy who's got to do it. So it depends on what we do for our ability to maybe make some estimates. But that's another type. But again, if we're looking at volume measurement, notice the units are going to be cubic units. And that's important. And when we get into, we'll get back to this conversion. This conversion system I've shown you only applies to single dimensions. If we do double dimensions, like area, if this was square feet, then all I got to do is I got to use this conversion factor twice, right? Because I need to get rid of feet squared. I got to get 2 of them gone. If this was volume, and this was 30 cubic feet, then I need to use this factor 3 times. So that's the only difference. So we see that once I learned this, that to convert from feet to inches is 1 multiplication, I can also use that same factor to do these 2 conversions. It's just, since it's squared, I'm going to need to use the conversion twice. Cubed, I'm going to need to use it 3 times. Multiply 3 times, and then I'm all good. Okay, we'll be able to do it that way. And again, a good method in this class especially is to have a backup system, like an online calculator, to do a check and help us to get a good feel, did we go the right way? Because here's the thing, is we're either going to divide by 12 or we're going to multiply by 12, right? So we could try one, and it might just not feel right, so we could do both of them and see which one feels like it's the right answer, because sometimes we have a good feel for it. Maybe we don't. If we got it wrong, try the other one and we'll probably get it right. Okay, so this is the dimensional analysis. This is sort of where I started. So this is where I go. What do we get when we divide a number by itself? We get 1. What do we get when we multiply by 1? We get the same thing back. So that's all that dimensional analysis is doing, is it's dividing something by itself. Again, they look different, but they're the same amount. So these are really 1. So when we're multiplying by 1, we are not changing what we have, we're changing how it's represented. So instead of 47 inches, we've got 3 feet, 11 inches, still the same thing that we've got, right? But we've got different numbers because maybe over in that factory, that's how they measure things, right? So you'll see this. This was from the old textbook. You know, and so you might want to do a screenshot of this or something. But this is in the text somewhere. It's just all these different conversion factors. So to use this unit analysis, we have to have this knowledge. You know, how many inches are in a foot? So we need this stuff here. And then units, we could also do it. Units, I just think of, if I go to area, I need to multiply by the same factors twice. Or you could go, if you're going to do it a lot, you go ahead and do that, and you use the squared factors. So that's a way to do it. Or if you're going to do volume, you use the cubed factors. But I never use it enough, so I remembered these, a few, 12 inches in a foot, 3 feet in a yard, 5,280 feet in a mile. And again, that one I don't really remember because each time I'm asked, I forget. And then there's these others. If you're a cook, you probably know some of these. There's a teaspoon, and 1 tablespoon has 3 teaspoons. I thought it was 2, but I guess I was wrong. So that's why all my stuff doesn't taste so good. So if it calls for a tablespoon, put in 3 teaspoons and you'll be fine. But Yeah, that kind of, I thought for sure it was 2, but anyway, flew it out. So we've got all these conversions, and again, if you're a good cook, you probably know these different conversions depending upon what you have. That's where you might need it. And also, we might need it to make a bigger, here's a recipe for 10 people. Oh, I got 100 people coming, so multiply by 10. Doesn't always work that way, but so that's another place is cooking and such that we do it. We use it for weights. We're checking if you're traveling, you make sure your suitcase is not over the limit because they charge you a lot of money for that. So we got to do, and then again, if you're going internationally, they're going to measure in kilograms. We measure in pounds. We need to know that conversion, and I think it's about 50 pounds is about 20 kilograms, something like it, 21, 22, 23. But sometimes if you're trying to, get as much stuff over to that place you're going as you want to get everything there, but you don't want to go over. So you might need either a converter or get a measuring device that will convert. And we're fortunate that we're in a world where there's really only the two. When I was in high school, they said we were going to go over to metric. But currently, the U.S., and there's one small country somewhere, I can't remember where it is, that doesn't use metric system. Every other country uses a metric system, and that would make our math classes even easier, because then we just go with metric. Okay, so, but anyway, that's what this is about. It'll give you all these conversion factors. So when we get to the homework, we'll see that's primarily what they're doing. Metric system is a system based on where everything is one power of 10 higher. So there's a millimeter, and then 10 millimeters make a centimeter, 10 centimeters make a decimeter, 10 decimeters make a meter. So, and then if you have 1,000 meters, that's a kilometer, and they'll use that instead of a mile. So it's kind of a decimal system, so they can get away from fractions. And we'll take a look at how we can do some conversions within this system between, say, centimeters to meters or kilometers, because with this system, you could use the same sort of thing of how, this unit analysis, but since it's all on powers of 10, you could also do it by moving the decimal. And you just, however many, you move it over. The thing is, you got to remember, am I moving it to the right or am I moving it to the left? Okay. Then with the metric system, because it's built on powers of 10, they use these common prefixes which come from Latin. So there is the 10 units is a deca. If I go to a tenth, it's a deci. So usually there's like what would be right here in the middle. Their main units are meter. Meter is their 1 unit. And then if you go with a decimeter, there would be a tenth of a meter. Centimeter is a hundredth of a meter, and that's kind of what they use mostly. Millimeter is a thousandth of a meter, so 1 centimeter has 10 in there. And then these, you kind of got to go to microscopic, right? The other thing that could be here is the same thing. Could be grams. That's why they measure thing 1 gram. Thing is when they're measuring things, usually they use a kilogram. It's 2.2 pounds. So if you're ordering meat and stuff, they'll use a kilogram, because a gram is about the weight of a paper clip. But again, the main things here, and then you can get smaller than the gram or larger than a gram, multiple grams, and we use those prefixes. And again, it just depends upon what you're doing. Some of you in the health profession, you may be at a hospital and you may see that, I think because international health has become, a lot of things are measured in metric system. Some places still use inches and feet and pounds and stuff, so you may have to convert. But again, some of the questions are going to be in the homework. We'll take a look through some of it, but they're going to ask you to kind of get a feel for how big is a meter. How big is a meter? It's about a yard. It's about like this. So centimeter, well, it's like this. So it's getting this feel for, is it big or is it smaller? How much is it? Millimeters really is 1/10. It's barely see it. How much is a kilometer? Well, that's equivalent to what we use for a mile, but it's like 1.4 kilometers to make a mile or something like that. Not quite 2, but more than 1. A liter, and again, we have some experience because a lot of our drinks are now in metric. So a little liter bottle, that's pretty good. The 2-liter bottle is maybe something you would share, but 1 liter is probably, if you're thirsty, it's a good size. Milliliters are small, grams, so forth and so on. What we need to do though is, since we're in the American system, we've got inches, we may need to make these conversions. And again, remember, I think this one it says is an exact, so 1 inch is maybe exactly 2.54, so it does divide evenly. But 1 gallon to 3.9 liters, that's an approximation because there's actually more decimals after that. So that's one of them. Since it's not an exact, if you use a conversion tool, conversion calculator, you might get a more accurate but slightly different answer than if you use this number here. And again, weight is also 2.2 pounds per kilogram. It's a good estimate, it's close, but it's not exact. Probably it's 2.2 something. Okay. So again, but if we're going to convert, we just need to know this equality, something, just like here, and then we can go from one unit to the next by coming up with one of these two, remembering that we're going to divide out the unit that we have. So if we've got inches, we want to divide out the inches. So the unit we're going towards will be in the top. What we're getting rid of, going from, is going to be in the bottom. And if we change it, we use the reciprocal. Okay. And again, some of these are and I think we're about ready to go. This one is, again, I took this from a Math for Elementary Teachers class. They get into more details. In this class, we'll just kind of get through doing it. So I think we have enough. Let me just see. I think that's what we do. Yeah, I think we could go to the quiz and we'll actually work through some of the homework problems together. And I think, most of it we're going to be doing is right here. So let me go to Chapter 1. So we'll go to the Chapter 1 quiz. And if you want to follow along with yours, you can, but it might be a little confusing because your numbers are going to be different than mine. I will reset it. And I'll just go for a teacher preview. Let me make it a little bit bigger. There we go. Okay, find the unit rates. Okay, oh yeah, so see, we had to come here. What's a unit rate? Well, we'll work through this together and we'll see what a unit rate is. So find the unit rates. If necessary, round your answers to the nearest hundred. Okay. Let's go with blue. So we're told that it costs $8.69 for 6 kilograms of something. So we want dollars per kilogram. What does the word per mean?
Divide.
Very good. Yes, so when you see the word per, think we're going to divide. So we're going to take the dollars divided by the kilograms for this one. So that is $8.69 in the top, dollars, divided by the number of kilograms, 6 kilograms. Now for this one, we just go ahead and plug this in our calculator. Pull this one up. 8.69 divided by 6 We come up with 1 point, and they say to the nearest hundredth, so that's 2 decimal places. So I'm going to write this as 1.45. The 4 got rounded up because next to the 4 is an 8. I'm more than halfway, so we're going to do this 1.45. And what's our units? That's dollars per kilogram. And what that basically do, you could think of, we divided everything by 6. That's saying that if I were to buy 1 kilogram, it would cost me $1.45. Okay, and so we could type that in. Again, you'll have different numbers, but you'll have the same process. Divide the two, and we get that. How about kilograms for dollars? Per dollar, not $4. We do the same thing, but in we do the reciprocal, right? How many kilograms do we have? We've got 6 kilograms, and that cost $8.69. And so we do the same thing, but the division is the reciprocal. So we've got 6 divided by 8.69. And that means that for $1, we can get 0.69 kilograms. We can't get a full kilogram for $1. Oops, 69 kilograms per dollar. And then when you do these, you can check your answer. Now with the quizzes, I think this means you can get 2 tries. So if you don't get it right the first time, which we did, I think you get a second try at it. You get 5 tries.
No.
Oh.
The homework, like it says it's already, like it was due. Yeah.
Oh, thank you. We'll change that after when we go through this. So yeah. Maybe I thought, anyway, I got so many classes, sometimes I don't know what I've done. But yeah, it's probably based on spring, maybe some of these. So I'll definitely move them out. The goal is you have at least a week, and then actually I'll move them out. You have until the exam to get everything done. But if I put all the due dates for the exam, some of you, I would probably be in that group, will wait till like the week before the exam to start doing the homework. So it's kind of to get you moving along. But if you don't get it done, we'll extend it so you still have time. But thanks for letting me know that. And again, if you don't have access to anything, feel free to email me. I do well with that, and I can check and I can get those going. So again, what's happening here is for the unit rates, it depends. If I want 1 kilogram, then I want to know how many dollars per kilogram that 1 kilogram is going to be. I need $1.45. If I've only got $1 to spend, I want to know how much I can get for my $1, and that's what this second one is telling me. I can only get 0.69 of a kilogram if all I got is $1. But usually, a lot of times, and for comparison's sakes, we could compare either one, but we'll use cost per unit, so dollars per kilogram, to compare 2 different products, which one's cheaper, right? Because we might have some other information. Any questions on that? So that's unit rates. Here's what I was talking about with the factor method. So we're given a number of centimeters. We want to use the factor method. We're given that there's 1 meter in 100 centimeters, 636 centimeters. So this is where we want to take our fact of 1 meter equals 100 centimeters. We're going to either use 100 meters, or 1 meter is 100 centimeters, or we're going to use 100 centimeters is 1 meter. Which one of these 2 will we use down here?
The second one?
So we've got centimeters.
Oh, the first one.
We want to divide them out. So that's, yeah, it's always, I always go with the wrong one first, but we want to use we want to use this one, And so we'll set this up with centimeters. Oops. And this is just a drop down. Centimeters in the bottom. And that's taken directly from the fact we're given. Meters in the numerator. And there's 1 meter. So we've just used this as our factor. That's what it's checking on us. And then how do we get our answer? Well, it's 636 divided by 100. And if we're dividing by powers of 10, you move the decimal as many places as there are zeros. When we're dividing, we get smaller, so we'll move it 2 places. So without a calculator, I can say I'm going to get $6 or 6.36. And then what are my final units? Well, the centimeters have canceled out, so the final units are what's in the numerator. That's meters. Okay, does that make sense? No? Okay. So 636 centimeters. Remember, we can multiply this by a factor of 1. Since they give us this factor here that 1 meter is going to contain 100, we get these 2. We either have 1 meter over 100 centimeters, or, again, this is the conversion factor system we used here. So we want to get rid of centimeters. So the centimeter part, this thing here, the 100 goes in the denominator, 1 meter goes in the numerator, and sort of what we're thinking is the centimeters are going to cancel. Take 636 divided by 100, and again, if you're not feeling comfortable doing that by moving the decimal, we always go here. 636 divided by 100, 6.36, and that's going to get us to meters. So again, part of it is thinking that centimeters is just a little bit, it's like a nub of your finger. Meters are the length of your arm, a little bit longer than that. So if we have 636 little things, we go to the bigger things, we'll have fewer of those, so we should be getting smaller. And again, whenever we have these factors, what we sort of knew is that we're either going to multiply by 100 or we're going to divide by 100, right, to do this conversion. If you multiply by 100, then you've got 6,300 or maybe 63. You got a really big number, and it maybe doesn't seem quite right. But again, you try it out. The nice thing is, if you go to the homework first, so you don't always have to do the quizzes first, but I do those so that we've got them recorded and you could see them. But in the homework, you get multiple tries. After you finish your last try, you can also, there'll be an option to try a new problem. They'll give you basically the same thing with different numbers. Okay, so you get multiple tries to work through them. Here's another one. Let's take a look at this, because this is going to be a little bit more complicated. So here's a unit conversion, and we're driving a car 350 miles on a tank of 24 gallons. So that's something we know. We can drive 350 miles if we fill up the tank to 24. How far can it drive on 50 gallons? Round your answer to the nearest mile. Again, what we're looking at is we're sort of converting gallons into how many miles would it be. Now, it's not, this is a little bit more abstraction. It's this particular car, how far could it go? So what we're doing is we're thinking that 350 miles is equal to 24 gallons, at least for this car. If I have 24 gallons, I can drive 350 miles. If I drove 350 miles, I must have used up 24 gallons. So again, using the conversion factor way, this gives us two fractions, 350 miles divided by 24 gallons, or 24 gallons divided by 350 miles. And remember, when we look to what we're doing, we always want to divide out what we're starting with. So we're starting with gallons, so we need the one with gallons in the denominator. Because again, remember, we talked about if you take a number divided by itself, that's going to cancel out and give us 1. So if we have gallons divided by gallons, that will cancel out and give us 1. Units are gone. So again, here what we're going to do, we know we need gallons in the denominator, and this particular car, it's 24 gallons for a full tank. That will take us 350 miles. Okay. And the math behind this is the gallons are going to cancel. So what's going to be left are miles. So we put that there. This is just a way they came up with where they can kind of assess you on each step. And then how do we get how many miles? Well, we're going to take 50 times 350 and then divide it by 24. Or you could do it in a different order, but that's with fractions. You multiply the tops and you divide by the bottom. Okay, so this is literally going to be $50 times 350. The denominator will be 1 times 24. So notice how I'm just multiplying straight across. And then at the end, whatever's in the numerator, we divide it by the denominator. So clear. So 50 times 350. That's a lot, 17,000 miles. But we divide that by 24 gallons. 729 to the nearest mile. There's a 1 here, so we round down to just 729, right? To the nearest mile, 7. And sometimes if you put in 729.1, it probably will mark it wrong. So you always look up here in the instructions. This wants it just to the nearest mile. And then just kind of a fill, yeah. So if I've got 24 gallons, this 50 is more than twice, right? 24 plus 24, that's 48. So this is about, I should be able to go about twice as far. So twice of 350 is 7. And then actually I've got 2 extra gallons anyway. So just kind of do a check for, does it seem like it's about right? If I did the math backwards, right? If I divide it, if I did the other one, then I would actually have a much smaller, right? So just kind of do an estimate. About twice as much gas should get us about twice as far. So how many gallons are needed to drive 1,850 miles? Again, same thing, but this time we're going to flip it, right? We're starting with miles and we need to know how many gallons we're going to use. So since miles is in the numerator, we use exactly the same conversion factor that we have here, except we start with miles in the denominator. So there's our 350. And in the numerator is going to be the gallons, 24 gallons. And so it's the same process, but different numbers. So we're taking 1,850 times 24 divided by 350, and what we're going to be left with is the number of gallons we would need in our car, or to be able to put into our car over time. So I'll write that over here. So it's 1850, multiplying fractions straight across. times 350. So I multiply the numerators, I get this number, I divide it by 350, and I get, and again, it wants the nearest tenth of a gallon, so that's a little different, so 126.8, but I look to the right, I've got a 5, 5 is halfway to the next number, so we're going to round that up to 126.9. So the 8 goes up to a 9. So we need that many gallons. We can check our answers, and we've got them correct. How are we doing on that one? Okay, and again, we'll have the rest of the day once we finish this. We go till 1:50. If you want, you can stay, you can go. And then we all have all day Tuesday working through the homework. And again, we'll get here. Now this one, they take away the scaffolding, so they don't show us how to do this, but we're going to do it the same way. This one's typically more complicated because there's two conversions that we're making at the same time. Okay, so first of all, I see this conversion factors here. So remember, those conversion factors give us two fractions. We'll write those up. So I'll take like we've got how many, $1 is about 0.876 euros. So that means that we've got maybe $1 divided by 0.876 euros. I think they do something like that. Or the other fraction we could get, 0.876 euros, bless you, divided by $1. So remember, those are the two fractions it gives me. I looked for the this top one where I've got two things that are equal. It's one divided by the other, or the other the flip. So we'll see. And then for gallons to liters, the same thing. We'll get two different conversion factors, either 1 gallon in 3.785 liters, or we have 3.785 liters in 1 gallon. So we're going to use one of those two. So we read up here, and what we're given is that the cost, 2016, the cost of gasoline in Berlin was around 1.22 euros per liter. And again, what does the word per mean? Divide. So that means we have a fraction of 1.22 euros per, or divided by 1 liter. So when it just says per liter, that's the same thing as saying 1 liter. And the question is what would be the equivalent cost in US dollars per gallon? Okay, so we're going to do two conversions. We need to convert the euros to dollars and the liters to gallons. Okay, so let's see if we can follow along. So which one, does anyone have a preference? Which one should we convert first? Top one. Okay, so we want to take euros to dollars. So if we focus on the euros, which one do we use? Do we use the first, do we use the A, or do we use B? We use the first one because, good, we want to divide out the euros. So we use this one. So that's going to give us $1 and 0.876 euros. So what I like to do is, as I'm doing this, I check. So euros divide out, oh yeah, I've got to be left with dollars. That's what I want. Okay. Now I'm going to do this at the same time. So I'm not going. You could calculate it and then do the next one, but on these, you'll see in chemistry, they set up ones like this. You're going to multiply by multiple ones. So now, what would which one of the units would I use here? I've got liters in the denominator. Do I use this one here, or do I use this? I use the second one. So the liters have to be in the opposite direction. So since liters in the denominator, I need liters in the numerator, so they'll cancel out. So I use my factors here, 3.785 liters, and my liters cancel. This liter cancels with that liter, and then in the denominator I have 1 gallon. Okay, so what this has done is there's 3 fractions here. With fractions, I'm multiplying them all. So I'm going to multiply 1.22 times 1, that's this middle piece, times 3.785. In the denominator, I'm going to take 1 times 0.876 times 1. And my units that are left behind, gallons are in the denominator, dollars are in the numerator, so I'm going to have the right units. I want to get dollars per gallon, so I'm going to be good. All I got to do is do this math. That number will go here, so that'll be dollars per gallon. So where's my calculator? Clear. 1.22 times 1, I'm not going to do that because that's the same thing, times 3.785. I'm going to hit equals. And then I need to divide by, so 1, I'm not going to multiply by 1 because, again, it doesn't change it. So I just need to divide by 0.876. Divided by 0.876. And we get that gas actually was costing, let's see, well, I guess I could just type it in here, $5.27 per gallon. See, did I get that rounded correctly? I didn't check real carefully. 527, next to the 7 is a 1, so yeah, I would round that to 7. So $5.27. Okay, so this is a little bit of a stretch, so it's 2 conversions, but we can just basically, take those 2 different conversion factors and multiply straight across. Again, those of you who take chemistry, not all of you will, but if you do, you'll see this in many times. And I remember some of the chemistry. I didn't really like chemistry, but I got through it. Sometimes there was 3 or 4 different conversion factors you needed to use to convert your units. Okay, so we'll check our answer, and we got it right. Okay, and with these, if you're using those conversion factors, if you're getting it wrong, it's probably because you used the wrong, you used the reciprocal. So just go back and use that. But you guys really seem to be pretty good, strong on knowing which one to use. You're dividing it out, you're using it. They have to be opposite of each other. All right. Questions or concerns? Got 2 more to do. And then again, these are kind of just getting you, these are what's in the homework. Time to work through. I'm happy to work with you and go through. So these are kind of application type problems more. So number 5, a long year-end status report for work is 110 pages long. Okay. You need to print 16 copies for a meeting next week. How much is the paper going to cost for those reports? Paper is sold in reams of 500 pages for $3.95 each. So each ream, and this is pretty accurate, you know, little grouping of paper, 500 reams. I think this is pretty cheap. Paper's usually $4 or $5. So give your answer to the nearest cent only for the paper you use. So they're saying, so this is where, you know, if you're going to have to buy these papers, you have to buy a full ream. Nobody's going to sell you a partial ream, but they're saying maybe they would sell you a partial ream. So what do we need to do? Well, we have this, basically this factor that 500 pages is equal to $3.95. That's sort of our, if I have $3.95, I can buy one ream, is what I'm thinking. And one ream will have 500 pages. So this is going to be my conversion factor. How much paper do I need? Well, each report is 110, and I need 16 copies. So first I got to figure out how much total paper do I need. How would I do that? Multiply. Good. So again, most of our answers either multiply or divide, and this time, yeah, we need 16. So obviously, if it was 100 copies, I'd need 16 of those, or 100 pages, 1,600. Oh, but I have 110. So first of all, I want to take 110 pages times the 16 copies. So this is not really conversion. Again, some of these are like problem solving. So 110 times 16 clear 110 pages times 16 copies, so everyone has one at the meeting. We're going to need 1,600 pages. What did I say? 1,760. See, I said I saw it, but I said the wrong number. So you got to be careful. And I was going to write that down. I said, wait, I thought I saw a 7, but I didn't say it. So 1,760 pages. And then we want to know how much it's going to cost. That means we want to be left with dollars. That must mean we're dividing out the pages, right? So that's kind of, it's, again, this is a problem solving. It's not really a unit conversion, but we're using the same technique. We've got how many pages, we want to know how many dollars. So we are going to divide out the number of pages. And what goes with the 500 pages, that will cost us $3.95. So that's going to be our units. And again, we see units canceling out, pages cancel out. We'll be left with just dollars. So again, thinking of this as a fraction, we multiply straight across and then divide. So this one is both multiplication and division. Pull up the calculator. So it's our 1760. We're going to multiply that by 3.95. And then we're going to divide it by 500. Or you could have divided first and then multiplied. It works both ways. You'll see. Probably makes more meaning, because if you divide it by 500 first, that would tell you about how many reams, right? Three reams plus some more, right? A partial ream. And so that's 3 times a little bit more, so $13.90, right? Rounding, so the 0 stays 0 because next to it is a 4, so it hasn't gotten halfway yet. $13.90. Does that make sense? So we use this for kind of problem solving as well. Check our answer. And again, if we got it wrong, it might be we did the wrong order, which is fine. Just switch it around, we'll probably get it right. Okay. Another one. So bicycle is traveling 12 miles per hour. How many feet will it cover in 45 seconds? right? So what are we doing here? We're dividing, and we're we're actually doing both. We're doing two conversions here, right? So we've got, what we want to write this is 12 miles per hour. We want to think of that speed is 12 miles per 1 hour. We actually have to convert, so we're looking to convert miles into feet, and we're looking to convert hours into seconds, right? Because that's what we want the units to be. We want it, how many feet, we want things to cancel out. So to get the number of seconds, right? I mean, we have to, there's a time conversion here and a distance conversion. Which one should we start with?
Distance?
Sounds good. So we could go with the 12 miles. Let me write it out. I'm going to go down here because I just got thinking we're going to have a long way to go. So distance 12 miles, we want to get to, well, actually not too far. We have it up here somewhere, right? How many feet are there in a mile? How many miles are there in a feet?
5,280.
5,280 feet is in 1 mile. So that's not too bad. So we've got 12 miles. Where do we want the miles? In the bottom. So there's 1 mile here and 5,280 feet in the numerator. So that one wasn't too bad. That, and we're now in the right units, right? We went from miles to feet. But this would be how many feet got covered in 1 hour. We want to see 45 seconds, right? So what do we need to, we need to convert this hour down into seconds, right? So how many seconds are in an hour? Well, I don't know, but I do know how many minutes are in an hour. 60 minutes in 1 hour. And I remember, I think, that there's 60 seconds in a minute. So I can convert down to seconds, and then since I've got 45, I would multiply by 45. So one way to kind of approach this is hours are in the bottom, so I want to get rid of hours, so I would use this one here, 1 hour divided by 60 minutes, right? And so that's going to, I guess I could do this, canceled out the miles, we'll be left with feet. We're going to cancel out the hours. We would be left with dividing by minutes, but we don't want minutes, we want seconds, right? So we have to convert again. And this time we use the second factor, or yeah, that there's 60 seconds in 1 minute. So the 1 minute goes up here. The 60 seconds go down here. And so minutes cancel. We would be left with seconds, but our units would be feet per second, right? And we want to know, we want 45 seconds, not 60 seconds. So this is actually getting us what we'd get in the 60 seconds. So this is miles per second, so we're going to multiply by 45 because otherwise we've converted into to feet per 1 second. We want to convert feet per 45 seconds. Does that make sense? Kind of. If you forget to multiply by 45, if you just convert the units, you'll see what you'll end up with is really feet per second. This is what, I didn't explain that well. So what we want, we don't want seconds. What we want is, we want to know, we want the seconds out of there completely. So what we're going to multiply by is 45 seconds. So the seconds get out of there, and now we'll have just feet. I mean, yeah, let's do it that way. 45 seconds. We'll cancel that out. So the reason we set it up like this, again, we've got multiple things, is we just go through and we multiply everything in the top. So we're going to take 12 times 5,280 times 1 times 1 times 45 in the top, and then we will divide by, from the bottom, 1 times 60 times 60 times 1. So we get the calculator ready. So 12 times 5,280, oops, messed up there. 12, 5,280 times 45. So I've multiplied everything in the top, and I'm going, that's wow, that's a lot. 2,851,000. 2,500,800. 2,851. 200. Okay. So that's in the top, and again, that's going to be feet. The bottom, as it goes through, notice all those are gone. But what's 60 times 60? Well, 6 times 6 is 36. There's 2 zeros, so to add 2 zeros at the bottom, so that's going to be 3,600 is what we'll divide by. 792. Thanks. Okay. So again, we've got that in there. That's not too bad. Divided by 3,600. Again, if you're not sure, you can use your calculator for any of this. So it means in 45 seconds, the bike will have gone 792 feet. And again, some of you are in forensics here. Is that right? Anyone in forensics? I don't want to. Okay, yes. Well, these are the types of problems you might be facing, is how far did that bike go and how fast was it going? And sometimes they work backwards with these things. They know how far it went. They can actually tell the speed of a car by how long it took to stop, those kind of things. So they, there's a lot of different use for these conversions. And again, here we're using it more for a problem-solving approach. But let me just do the check. So if you have the same values, you've got the quiz part done. Remember, this is as much as the homework. And then what we have left to do, I'm just going to leave here. I'll just do a quick preview of the homework, which you'll be able to see. And you can go in and out of these. September 13th. I have a due date of September 13th, but you're saying, what is your...
It says March 22nd, or March 7th is that's when it should have been done.
This assessment was due, oh, it's not, they're supposed to be matching up. I have to go into the more, this one is supposed to drive that one, but it's not, so thank you. So yeah, so this was from spring term. It was supposed to be updating. I'll have to figure that one out. But you'll see you've got, there's a few things we didn't talk about. Actually, you know what? Since I have to go in, there's this stuff on fractions that we didn't really cover. It's not, you'll get into it once you start doing all this stuff. Where I want you to really start is question 5. So let me, since I've got to go into more anyway, let me do that. I'm going to see if I can delete those first 4 questions. See, it says, oh, I'm in the wrong class. I was going, that's why it's got that 2 day, okay. Um, Okay, here we are, and we're Math 140. I thought I copied over to here. Course content should be here. Measurement for 1 should be here. And the homework. I'm going to do this. This is September 6th. Let's make it do...
That's 2022.
Oh, thank you. Wow. That wouldn't have helped much. So we've got to be 2023. We meet to, let's go till the 19th, I think is when I wanted it. Keep open for ungraded practice, available after that day, that's fine. Show by dates. I want to also okay, I think I have to save changes. I think to delete them, questions. Let me just do that, because it's not that they're bad, but it's not really what I want you working on. I think I can withdraw it. Okay, so that's gone. You're going to get enough practice with fractions as we go through things, so I'm just going to take it off. Right, fractions. So those are done, and then we're into the unit conversions. So let me save that. Now, if someone could try to get into the homework, is it going to work? Do you have access? Because I don't want you to go home and not have access.
Yeah.
You got it now, okay.
Can you also open up the quiz? Well, when you have the chance, you don't have to.
No, I better do it now because I'll forget. Because I got another class after this one, and then I get home late, and then, yeah. So we'll get you your quizzes. Homework quiz, chapter 1. Oh, geez. Yeah, these were all supposed to be updating, but we'll get it all settled. But thanks for letting me know. So thank you all. Again, you're welcome to hang out. You're welcome to head out. Yes.
Are they due at 11:59 at that day, or at a certain different time that day?
Actually, it's showing 10:59, but I've got them in the future, like for 2 weeks from now. So you should get them. So those should, and I'll move them again to about the test date, so it shouldn't cause any problems.
Okay, thank you.
You're welcome.